So, welcome everyone to the presentation on the HPC Lab. So, the HPC Lab is the lab that belongs to the HPC SIG team, of course. It's hosted in the London Colo, and we're going to present its goals and problematics and how the infrastructure is designed. So, what is the goal of the HPC now? Mainly, so we have two principal goals. The first one is to test OpenHPC deployment on our clusters. So, automate this process and validate that everything is going all right. The second goal is to do benchmarking on our HPC machines and investigate performance, optimize, and in general, see how the compilers respond to our architectures. We have multiple requirements, of course. So first of all, stability. Of course, we need a stable lab to work with. Repeatability, because all this work must be done upstream as well and repeated. Close production environment, so that what we do can be used in production use cases. Use upstream technology, of course. This is Monaro's mission. And we have to isolate the results from each vendor's machine, because we have binding contracts, of course. Here we can see a general overview of the lab with the multiple machines. This symbolizes our different vendor clusters and the x86 machines. And this is the administration services. So we have the master admin server, which hosts all of the services, including Jenkins, the provisioner, and the file server. And the file server hosting the results from the benchmark and the results from the different tests we run. And then we have different networks, 1 gigabit, 10, 40 gigabits, and InfiniBand, 100 gigabits networks. And plus we have some management of the power supplies and the BMCs here in the management network. So to delve a little more into the network layout, so we have, I've listed them, but so we have a 1 gigabit uplink network to provision sorry, that's not it, that's one. To provision our different machines and to communicate with the SFTP, the file server. Then we have another management network, the BMC network, with all the machines plugged into it in a flat format. And then we have the distributed file system network, when Lustre and Seth will come to the lab, it will be there for that. And then we have the IB network, 100 gigabits, on which we will do MPI and internal provisioning, meaning the master provisioning the slaves in our clusters. So, how do we meet the requirements of the HPC Lab? So, concerning stability and repeatability, for example, we cache, for example, the tool chains we use on the benchmark, so we can always find them. They don't disappear since they come from the CI of the TCWG group. Close to production environments, we keep our hardware up to date. And concerning the upstream technologies we use, we only use open source directly pulled from upstream services. So Mr. Provisioner, the provisioner, and Jenkins, the job dispatcher, as well as the SFTP OpenSSH server. Concerning the vendor isolation, all of the HPC Lab is behind a VPN. And concerning the benchmark results, it's all isolated into different SFTP folders. And additionally, we have, of course, rights management on the jobs in the Jenkins as well as in the provisioner. All of this hooked to LDAP. So one big mission of the HPC Lab is having a proper automation of the OpenHPC installation process and run process. So at the moment, OpenHPC, we have, with our workflow and Ansible automation framework, we can install it on ARM and x86 machines, on bare metal as well as VMs. The main part of the work has been done by Kato-san from Fujitsu. So we have been focused on CentOS Werewolf OpenHPC because XCAT and PBS Pro, the alternatives to Werewolf and Slurm, do not run on Arch64. We could easily port change from CentOS to OpenSUSE for stability's sake and to work more quickly. We only use CentOS at the moment, but that is something we'll do in the future. OpenHPC comes shipped with a test suite that allows us to validate that the installation process has been going smoothly. And so this framework and these recipes will be upstreamed, and other labs' recipes will be integrated into one single package. This will be done by Lenaro, and then will be upstreamed. So this is a process that is ongoing and will be ongoing in the future, and this represents quite a bit of work. The idea, is to have a single Ansible recipe to unite them all and allow users to fine-tune it as they see fit. We do not have yet full support of InfiniBand. Pak will talk about InfiniBand. But all tests, and not all tests are going through, especially Lustre. Yes?
Would you mind if I ask you in the middle?
Sorry. Can you just...
I hope you don't mind I ask in the middle. So one of the problems I had with InfiniBand and CentOS was that CentOS doesn't keep the RDMA libraries updated. And this is the biggest challenge you will face there, right? Because I had so many problems backporting all the libIB verbs, libmelanox, and all those libraries into Ubuntu. Oh. So I was thinking about that. Have you thought about it?
You're saying that you want to port to Ubuntu? Or?
No, I mean like I came from Canonical and I was backporting the libIB verbs, libmelanox to Ubuntu, and this was the biggest problem for having InfiniBand supported. So when using CentOS, to enable InfiniBand features for RDMA, for example, you will face lots of trouble if you don't update userland.
Yeah, it was old, but also we have also another challenge about the InfiniBand cards that we use. This is called Circuit Direct, which I'm going to talk about later on.
Oh, great.
But yeah, we do run into some issues too.
Thank you.
No problem.
So,
here you go.
I'll leave it.
Yeah.
InfiniBand.
Okay, so thank you, Baptiste. I'm Park. I'm Park Louis from Huawei Technologies. So I'm here to talk about some of the things that we're doing in Narrow for the InfiniBand testing. So we have been, having the IB switches and Mellanox Kinetics 5 cards on some of the clusters. So one of them is the Huawei cluster. So in previous slides, you see Baptiste shows you that there are other InfiniBand clusters that we have. So we're using something called Kinetics 5, but it's it's a little different. It's called Socket Direct, which basically means that we have like the card actually split between the two sides of the CPU. So on a Gen 3 by 8, you have the main card, and in another Gen 3 by 8 from CPU 2, you also have another auxiliary card. And in between them, you have like a cable that connects between them. It's called Socket Direct. So using that actually will require something that that is from Mellanox OFET. So the inbox that comes from the OS does not have the support in the OpenSM. So what actually means is that you get a connectivity for one of the IBHCA on the one side of the card. But in order to be able to use like both sides of the cards, but that actually would not be able to work. So we have to switch to using the closed source driver for Mellanox. It's called Mellanox OFET. So this is one of the issues that we have seen for Socket Direct. The Qualcomm cluster, which we also have in an arrow, are using something called multi-host. That's based on the Kinetics 4, which is also EDR or 100 gigabit Ethernet cards from Mellanox. That also have the same problem that the open source driver for IP actually is not there. So when me and Renato try to play around into bringing it up, what we see is that the Qualcomm server is supposed to be like a 1U2 system. So they both sides of the system share the same Kinetics 4 multi-host card. So as soon as you try booting up that, the left side, the right side does not have the IP card show up. So which is really weird. And then when we realize is that after we load the Mellanox OFET, and then both sides will start working, right? So this is like another weird things that we have seen when we use the inbox driver. The auxiliary card is also won't show up on the Socket Direct. So let me see what else we have to talk about. And then in the labs in the US, like the DOE labs, they also have ARM servers. So what they have realized is the same. They are actually also tried doing this and ended up using the Mellanox OFET to get around this issue. So we believe that if Mellanox cannot upstream that part for some reason, because they believe that it's something that they may take a long process for them to bring it upstream. I personally came from Mellanox before, so I know the kind of what they have dealing with. So the process itself it takes a long time for them. So for us, we have to work around it, such as having a fake node or some other node that runs a persistent OpenSM daemon using Mellanox OFET, or we can try to run it on a managed switch that has the SM running. So this will be a workaround for us because we're constantly reloading and bringing the tests on the nodes. So it's very hard for us to have like a closed source driver being up for the installation process takes a long time. So it's like 20 minutes to build the Mellanox OFET for our specific kernel version that we're testing against. Another 20 minutes is to kind of install, and then to reboot is another 10 minutes. So it's like an hour extra effort to do it. So Renato knows best about this process. But so another thing that we also try doing is to have a separate partition on the switch by using something called PKey, which we'll be trying because we want, as Baptiste showed, that we want to have a separate process for segregating all the networks on the switch for the InfiniBand side as well. So for Ethernet side, you can use like a subnet. You can use a VLAN. So another thing that we have tried doing is to do the Lustre. Lustre, we try to realize what the issue is for Lustre. Lustre does not work for ARM on the server side. And it's actually kind of, it has, even for the client side, it needs to have a little trick to make it work. So we are using the latest version of Lustre 2.11.54, I guess like 2.11.55 or it's out like a few days ago. And we have documented it also in the Linaro link over there. So on the client side, it has a problem. Actually, on the server side, it has a problem building something about the deversing pointer of one of the structures is failed in configure. So we have still have many steps needed to do in order to figure out what actually other issues in the server side. But on the client side, we try having an existing x86 server running, so we can just connect the client from on ARM to it. So that actually has been said that it would work. So when we tried it, so we are using the Mellanox OFED driver. We were able to build on the client. The Lustre client actually depends on something called, there are two modules that actually depends on. I think one is called SPL, the other one is called CFS. Lustre doesn't use, for the default one, doesn't use the LTSFS, which has been kind of like default from the past, but CFS is actually been the default one right now. We're able to build, we're able to create the packages, but when we try to do pinging over IP over IP, it has a problem saying something like input-output error using IP over IP interfaces. So what we have discussed with the folks that actually have tried it before, mainly from the folks in the U.S. labs, national labs, like Sandia and a few other ones like Oak Ridge. So they told us that they have run into similar issues, and they work around it by adding something called map on demand equals 16. So to enable something called like a fast memory registration, which is particular for the Kinetics 5 adapter. So this is a little bit new to us. So at the end, we were able to get the client mounted and working on the x86 server. So we'll be continuing working with Webb Cloud for have a consistent state for ARM, and Lustre 2.11, which will be released by Webb Cloud by end of October 2018, will have the ARM Lustre client support. So we were using 2.11.54, right? 2.12 will be the one that has the ARM support without patching. And then we're also looking for bringing back OpenHPC support for Lustre on ARM, the client side that is. That piece actually has been not there, so we really want to bring it back. So when 2.12 is available. Okay, so now this part I'm bringing back to you.
So concerning the other mission of the lab, the compiler benchmarking, we have developed a very simple harness whose goal is to run multiple benchmarks, whether it be, at the moment we have Lustre, Shimano, we're working on bringing more, and there is a hacking session on Thursday. So hacking of the benchmark harness. So in the harness itself, we have a process to auto-detect which architecture and which compiler we will use to run the benchmark, if not provided by the user. Of course, we support giving arguments to the benchmark itself to run, and setting multiple runs, and the size of the benchmark, and those kind of benchmark-specific arguments. All of the results, the benchmarks are run via perf, and then all of the results, whether it be the standard output and the perf output, is passed and outputted into YAML, which can then be analyzed by another program that will be that we are working on. This benchmark harness in our lab is driven by Jenkins jobs, and in the long term, we think of having Jenkins fire benchmarks on all the machines at the same time, and having different runs and comparing all of them. Of course, the results are moved and access controlled on the file server. And so the future of the benchmark harness is to add more benchmarks, eventually modify the architecture of the benchmark harness to support as many benchmarks as we can. And through the hacking session, we want to see the shortcomings of our infrastructure and add different benchmarks and see as well as how to parse the results and how to generate relevant analysis for the compiler benchmarking. So to sum up the current issues we have right now, so the big part of it is upstreaming the Ansible OpenHPC work. As I said before, we're going to do it in Linaro itself, pulling all of the different labs all over the world that have already developed their own Ansible recipe to install OpenHPC together and try to make one single package to unify them all. So we will do all of that in Linaro and then merge upstream. InfiniBand support, as of right now, relies on closed source drivers. That is a problem. So since we, as Pac said, we need socket direct and multi-host, we need everyone to be pushing code for Meladocs to upstream. For Lustre, same problem. We need upstream support for ARM. The client needs special changes, and the server, the Lustre server, needs kernel patches, which is a problem, and has been scrapped from the staging kernel tree. That is a problem as well, so that will need work in the future. And for the benchmark harness, so more support for more benchmarks and the result analysis to be there and to give relevant results. How we're going to deal with these issues. So I talked already about the OpenHPC Ansible upstreaming, InfiniBand. We need to deploy open source drivers and have a process to automate the installation of OpenSM if we're not using it on the managed switch. We need as well OpenMPI tests and basic validation that InfiniBand works in our Jenkins jobs, and that is independent from OpenHPC. Lustre is an issue of having the client work on our ARM64 and very long term having the server work as well and having it upstream in the kernel, and bring back a Lustre client support in OpenHPC. For the benchmarks, add more benchmarks and add multiple analysis of the results, whether it be for one benchmark or comparing different benchmarks on different machines. And finally, we will look into OpenMPI as well, make it work, make it stable, test it, make sure there are no regressions via regression tests, and ensuring it works well with our clusters and our lab. And that's it. Thank you. Are there any questions? I'm sorry if you could speak into.
Is there any plan to add any distro support like Red Hat? Why is that?
So the next distro that we plan to add is OpenSUSE. So OpenHPC is officially supporting CentOS and SLES, right, the proprietary version. But what I've been told is OpenSUSE is identical to SLES, and CentOS is identical to Red Hat. So if it works on CentOS, it works on Red Hat. If it works on OpenSUSE, it works in SLES. And if there is any difference, then Red Hat, which is a member, will help bridge the gap. So we don't need to test Red Hat, because for us it's a big hassle, because we have to get the licenses and have a license server, and it's a completely different setup. And same thing with SLES. So if we make it work in the open source version, if somebody else cannot make it work with Red Hat, then we will bridge the gap with Red Hat.
Thank you.
Any more questions? Oh, thank you for coming.